Hello and welcome to the Statistics for Data Science lecture series. This is a beginner friendly course, so we'll be covering the terms and terminologies one by one, and we'll get into the details of all the terminologies that we'll be using. Okay, so without further ado, let's start the video. So we'll start off with the definition. So statistics is an applied science concerned with analysis and modeling of data. Statistics is basically, especially in our data science context, we'll be using it for analyzing our data and to make decisions out of it, right? It helps us in decision making. So statistics is like a great tool for us. So in this course, will help illuminate these concepts and clarify their importance in the context of data science and big data, right? So we have some data categories. Okay, there are three data categories, namely structured data, semi-structured data, and unstructured data. So what is structured data? Structured data is highly specific and stored in a predefined format. Usually it's a table. Example are credit card information, stock market information. Okay, whenever we store it in the form of a table or a tabular structure, we usually call it a structured data. Next, we have semi-structured data. So semi-structured data does not follow the format of a tabular data model because it does not have a fixed schema. Okay, schema as in model, there is no structure to it, or it is not predefined. Okay, maybe the column names, all that, none of that is there. It is likely to, it can vary, as in whatever the need is, it can adjust to it. Okay, however, the data is not completely raw or unstructured and does contain some structural elements such as tags and organizational metadata that make it easier to analyze. Examples: emails, data stored in JSON formats, etc. So finally, we have unstructured data. Unstructured data is information that either does not have a predefined data model or is not organized in a predefined manner. Okay, so here the data is like very raw, and we need to process it to make sense of our data. Okay, so some of the examples would be news, then data from IoT devices like sensors, etc. Right? Okay, so let us look at structured data. So there are basically two types of structured data: numeric and categorical. Numeric data comes in two forms. One is continuous, such as wind speed or time duration, and discrete, such as count of the occurrence of an event. Right? So we can further categorize numeric data into two parts. Okay, so continuous and discrete. Next, we have categorical data. So categorical data takes only a fixed set of values, such as maybe the type of a TV screen or a state name, etc. Okay, so binary data is an important special case of categorical data that takes only two values, either a 1 or 0, or a yes, no, true, false, like that. Okay, so next we have key terms for data types. So here are a few essential terms or important terminologies which we'll look at. So at first we have continuous. So data that can take on any value in an interval. Okay, so whenever a data can take up like any value. For example, if you have, say for example, if we have 0 and 1. Okay, 0 to 1. So if our data is able to take 0, 1, 0.5, 0.75, 0.0014, it is able to take up any values in the interval 0 and 1, right? So then we say that it is a continuous data. Okay, next we have discrete data. So data that can take on only integer values are called discrete data. For example, in the range 0 to 1, if our values can only be 0 or 1, then we'll call it discrete. Okay, next we have categorical data. So data that can take only a specific set of values representing a set of possible categories. So categorical data, for example, suppose we have a basket of balls, and therein we have three types of balls based on its color. So one is green, blue, and red, for example. So this will be a case of categorical data where if we try to separate the balls, we'll be able to separate it based on these three possible color categories, right? So fine. Next we have binary. So this is a special case of categorical data with just two categories. So if it can be like hot, cold. Okay, suppose the day is hot or cold. It can be like there are, you can describe the day in other climate weather conditions as well. It can be windy, it can be snowy, all that. But basically if we are supposed trying to categorize it based on two values, for example today was hot or cold, then it will be a case of binary data. So let us now move on to the next part. This is rectangular data. So a rectangular data is basically when, for example, one example of rectangular data would be a spreadsheet, okay, or a pandas data frame. So when we are using or storing data in a particular format, especially when in in the format of rows and columns, we call it a rectangular data. So the typical frame of reference for an analysis in data science is a rectangular data object like a spreadsheet or database table. Okay, so there are a few terms which comes with rectangular data. So let us look at each one of them. So data frame. Rectangular data is a basic structure for statistical and machine learning models. So data frame is nothing but a similar representation of data as we see in spreadsheets. Okay, so and in fact this pandas library already have an object called data frame, which stores data in a rectangular format or like a spreadsheet. Okay, next we have feature. So column in a table is commonly referred to as a feature. So feature is basically nothing but the columns of a spreadsheet, similar to the columns of a spreadsheet. Next we have outcome. So outcome is basically when features are used to predict a certain value. Okay, so when we are predicting or when we are trying to arrive at a decision, so this output or this outcome column gives us the answers to our questions based on our input features, right? So that is what is outcome. So some other synonyms used are target, output, etc. Next we have records. Records are nothing but the rows of a table. So a row in a table is commonly referred to as a record. This is an example like what a rectangular data looks like. So we have these rows, all these rows, you know, these are rows and these are columns or features. Okay, so we call these records, these as features, all this. And there will be one column which will use all the other features or maybe some of it which are important and draw conclusions, and that is the outcome or the target column. Okay, which is used to predict something or to draw conclusions. Next we have is non-rectangular data structures. So we have time series data, spatial data structures, and graph data structures. Okay, so let us look at each one of them. So time series data. So in this case, the records are made successively of the same variable. Okay, so basically we are trying to look at how a variable is varying or changing with respect to time. It is the raw material for statistical forecasting methods and is also a key component of the data produced by IoT devices, right? Next we have is special data structures. So special data structures are used in mapping and location analytics and are more complex and varied than rectangular data structures. In the object representation, the focus of the data is an object, for example a house, and its special coordinates, for example the latitude and longitudes, right? Next we have graph or also network data structures. So it is used to represent physical, social, and abstract relationships. For example, a graph of a social network such as LinkedIn may represent connections between people on the network. Okay, distribution hubs connected by roads are an example of a physical network. Graph structures are useful for certain types of problems such as network optimization. So I think this is it for this video. We are going to look at a lot of things in the next video, starting from uh, estimates of locations, then we look at the terms mean, weighted mean, median, mode, and the different visualization techniques which we need to understand our data. Okay, hope you found this video helpful. Subscribe to this channel if you like our videos, and hit that bell icon to never miss an upload. Thank you so much, and I hope to see you guys very soon.